Hello dear learners, I Kamini Rathore welcome you all to SWAYAM online course. Today we will discuss lecture number 25 from module 8, that is confined space and safety. In this lecture we are going to learn about confined spaces, classification of confined space, hazards involved in confined space and principles of safety precaution. After that we will go through key acts, rules, regulations related to confined spaces, and we will also know about officers and authorities who are involved in confined space safety. Many workplaces contains space that are considered to be confined because of their configuration hinders the activities of any employee who must enter into, work in and exit from them. In many instances, employees who work in confined spaces also face increased risk of exposure to serious physical injury from hazards such as entrapment, engulfment and hazardous atmospheric conditions. Confinement itself may pose entrapment hazards, and work in confined space may keep employees closer to hazards than they would be otherwise. For example, confinement, limited access and restricted airflow can result in hazardous conditions that would not normally arise in an open workplace. The term permit required confined space refers to those spaces that meet the definition of a confined space and also contain health or safety hazards, thereby requiring a permit for entry. Permit required confined space also has one or more of these characteristics. First, has the potential to contain a hazardous atmosphere. Second, contains material that has the potential for engulfing an entrant. Third is, has an internal configuration that might cause an entrant to be trapped or by inwardly converging walls or by a floor that slopes downward and tapers to a smaller cross section, or the fourth number is contain any other recognized serious safety or health hazards. So that we can say a space that are large enough for an employee to enter and perform assigned work and has limited or restricted means of entry or exit and is also designed for continuous occupancy by the employee is called confined space. Let us move forward and learn about the classification of confined spaces. But before we acquire knowledge about this, it is necessary to know how confined spaces are identified. National Institute for Occupational Safety and Health defines a confined space as one that by design has limited openings for entry and exit, unfavorable natural ventilation that could contain or produce dangerous air contaminants and is not intended for continuous employee occupancy. Some confined spaces are fairly easy to identify. For example, enclosures with limited openings. These are storage tanks, silos, reaction vessels, enclosed drains, sewers, wells, tunnels, pits, caissons and shaft. Other may be less obvious but can be equally dangerous. For example, chambers, vents, combustion chambers in furnace, pipes, unventilated or poorly ventilated rooms, flues and hatches. Confined space can be found in many industrial settings, from steel mills to paper mills, from shipyards to farms and from public utilities to the construction industry. The hazards associated with confined spaces can cause serious injury and death to the worker. Two major factors lead to fatal injuries in confined spaces. First is failure to recognize and control the hazards associated with confined spaces, and second is inadequate or incorrect emergency response. The emergency response is usually a spontaneous reaction to an emergency situation and can lead to multiple fatalities. Let's now move to the classification of confined spaces. First is open-toed enclosures with depth that restrict the natural movement of air, for example, terraces, pits, selected type of tanks and excavations. And second is enclosures with limited openings for entry and exit, for example, sewers, tanks and silos. The hazards found in any confined space are determined by the material being stored or used, by the process taking place inside the place and by the effect of the external environment. Worker entry into confined spaces may occur during construction activities or during frequent necessary functions such as inspection, repair or maintenance. Here some questions arise such as what is limited openings and unfavorable natural ventilation in confined space. Let's talk about the limited openings. Confined space openings are limited primarily by size or location. Openings are usually small in size, perhaps as small as 18 inches in diameter. An access door or portal that is too small to allow an employee to walk upright and unimpeded through it is considered to be limited access or exit. These small openings may make it very difficult to get needed equipment in or out of the spaces. Confined spaces can be hazardous and they can be hazardous in varied ways. Oftentimes, the confined space will not appear to be hazardous. It may have been entered or prior occasions without incident and may give no apparent sign of dangers. At other times, there may be ready indication of danger. The distinct odor of irritating or toxic atmospheres, the presence of arcing electrical equipment, continued mild shocks or flowing grain or scent. By their nature, confined space concentrate hazards, atmospheric hazards, in that certain gases will displace breathable air or that the confined space will allow the accumulation of toxic hazards or flammable or explosive atmospheres, and physical hazards, in that confined spaces limit the ability to avoid contact with electricity, moving mechanical components or machinery or unstable substances. Access to open-toed spaces may require the use of ladders, hoists or other devices. Escape from such area may be very difficult in emergency situations. Ladders and temporary movable, spiral or articulated stairs are usually considered limited or restricted means of egress. Fixed industrial stairs that meet OSHA standards must be considered limited or restricted means of egress when the conditions or physical characteristic of the space, in light of the hazards present in it, would interfere with the entrant abilities to exit or to be rescued in a hazardous condition. Let's move forward and talk about the unfavorable natural ventilation. Lack of air movement in any out of the space can create an atmosphere much different than the outside atmosphere. Also, deadly gases can be trapped inside, which results unfavorable natural ventilation. Organic materials can decompose in confined spaces and may not be enough oxygen due to presence of other gases or chemical reactions such as rusting. Most confined spaces are not designed for workers to enter and work in them on a routine basis. They are designed to store a product, to enclose materials and processes, or to transport products or substances. The distance an employee must travel in a space such as tunnel to reach a point of safety can be determinant of classifying a space as a confined space. Therefore, occasional worker entry for inspection, maintenance, repair, cleanup or similar tasks is often difficult and dangerous due to chemical, distance or physical hazards within the space. Let's see the different types of hazards involved in confined spaces. Many workplaces contains space configured in such a way to be considered confined. Confinement itself may pose entrapment hazards. Working in a confined space may keep employees closer to hazards. For example, confinement, limited access or restricted airflow can result in hazardous conditions that would not arise in an open workplace. Hazards in confined spaces are separated into atmospheric hazards and physical hazards. Many substances have short-term exposure limit in addition to 8 hours time weighted average exposure limits. The permit required confined space rule is intended to protect against short-term acute hazards. Exposures at or below the permissible exposure limit do not fall under the permit required confined space rule. The atmosphere in a confined space may be extremely hazardous because of the lack of natural air movement. These characteristics of confined space can result in oxygen deficiency, flammable or toxic atmosphere. You can see in oxygen scale, an oxygen deficiency atmosphere has less than 19.5% available. When oxygen level drop below 17%, there is increased breathing volume, accelerated heartbeat and a deterioration of night vision, which is usually not noticeable. Oxygen atmospheres with 14 to 16% oxygen contribute to poor muscular coordination, rapid fatigue and intermittent respiration. At 6% oxygen, there is a rapid loss of consciousness and death in minutes. Any atmosphere with less than 19.5% oxygen should not be entered without a National Institute for Occupational Safety and Health approved self-contained breathing apparatus or a NIOSH approved supplied or breathing apparatus. The oxygen level in a confined space can decrease because of the type of work being done, such as welding, cutting or brazing, or it can be decreased by certain chemical reactions such as rusting or through bacterial actions such as fermentation. The oxygen level is also decreased if oxygen is displaced by another gas such as carbon dioxide, argon, helium or nitrogen. Total displacement of oxygen by another gas such as carbon dioxide will result in unconsciousness followed by death. Flammable atmospheres generally result from evaporation of flammable liquids, byproducts of chemical reactions. Enriched atmospheres or concentrations of combustible dust. Two things make an atmosphere flammable. First is the amount of oxygen in air and second is a flammable gas, vapor or dust in the proper mixture. Different gases and combustible dust have different flammable and explosive range. You can see the figure of ignition triangle. In this figure, when a source of ignition, for example, a sparking or electrical tools, is introduced into a space containing a flammable atmosphere, a fire or an explosion can result. An oxygen enriched atmospheres above 23.5% will cause flammable materials such as clothing and hair to burn violently when ignited and may cause some non-flammable materials to ignite. Therefore, never use pure oxygen to ventilate a confined space, ventilate with normal air. Let's talk about toxic atmosphere. Because of air cannot freely move in and out of confined spaces due to the design and configuration, the atmospheres inside a confined space can be very different from the atmosphere outside. Deadly gases may be trapped inside, particularly if the space is used to store or process chemicals or organic substances that may decompose. There may not be enough oxygen inside the confined space to support life, or the air could be so oxygen rich that is likely to increase the chance of fire or explosion if a source of ignition is present. Toxic atmospheres can be caused by the product stored in space and may contain a toxic components which could be absorbed into the walls and have the potential for release depending on the use of the space. It is also caused by the type of work being performed in a confined space. Example of such include welding, cutting, brazing, painting, scraping, sanding and degrazing. Toxic atmospheres are generated in various processes. For example, cleaning solvents are used in many industries for cleaning. The vapor from the solvent can build up to toxic levels in a confined space. Toxicant produced by work near confined space can enter and accumulate in confined space. Let us see the physical or general hazards. In addition to the areas discussed above, evaluation of a confined space should consider the following potential hazards. Temperature extremes. Extremely hot or cold temperatures can present problems for workers. For example, when possible, a steam tunnel should be allowed to cool before entering. Engulfment hazards occur when loose granular material stored in bins and hoppers such as grain, sand, coal or similar material can engulf and suffocate a worker. The loose material can crust over or breach over in a bin and break loose under the weight of a worker. Noise within a confined space can be amplified because of the design and acoustic properties of the space. Excessive noise can not only damage hearing and reduce reaction time to hazards, but can also affect communication. This can cause a shouted warning to go unheard. Slips and falls can occur on a wet surface, causing injury or death to worker. Spaces that have an internal configuration, inwardly converging walls or a floor that slopes downward and tapers to a smaller cross section increase the hazards of slipping and falling. Different material containing in the space may react differently in a wet environment. A wet surface will also increase the likelihood for and affect the electric shock in area where electrical circuits, equipment and tools are used. Workers in confined spaces should be mindful for the possibilities of falling objects, particularly in space that have top side opening for entry and where work is being done above the worker. There are some basic principles for safety precaution in confined space, such as avoid entering confined spaces, for example, by doing the work from outside. If entry to a confined space is unavoidable, develop and implement a safe system of work and devise an appropriate emergency plan before the work start. You need to check if the work can be done another way so that entry to or work in confined spaces is avoided. Better work planning or a different approach can reduce the need for confined space working. Ask yourself if the intended work is really necessary or if you could modify the confined space itself or other plan to eliminate the confined space. Have the work done from outside, for example, blockages in silos can be cleared by use of remotely operated vibrators or air washers. Inspection, sampling and cleaning operations can be done from outside the space using appropriate equipment and tools, and remote control monitors can be used for internal inspection of vessel. If entry to a confined space is unavoidable, a safe system for working inside the space should be developed. A competent person should be appointed to carry out a risk assessment of the conditions and the work and activities to be conducted in the confined space, and identify the necessary safety precaution to be taken accordingly to the findings to avoid posing hazards to workers. The competent person should make recommendations on safety precautions to be taken having regard to the nature of the confined space, the associated risk and the work involved. Make sure that the safe system of work, including the precautions identified, is developed and put into practice. Everyone involved will need to be properly trained and instructed to make sure they know what to do and how to do it safely. There are some checklists which is not intended to be exhaustive but includes many of the essential elements for reference to help prepare a safe system of work. This checklist includes appoint suitable person for the work, isolation, cleaning and cooling before entry, check the size of the entrance, provision of ventilation, testing the air, provision of special tools and lighting, provision of personal protective equipment, issuance of safety certification. Suitable workers should meet the requirements such as they have received training to become certified workers, have sufficient experience in the type of work to be carried out, have a suitable build for the work if the risk assessment highlights exceptional constraints as a result of the physical layout. He fit to wear breathing apparatus if the work requires the use of such apparatus and there is no medical advice against an individual's suitability to work in a confined space. Also remember, disconnect and properly lock off the power system of all the machinery and equipments that could cause hazards in a confined space. Blank off pipelines and service pipes with content that could cause hazards. Take effective steps to prevent an ingress or inrush to the confined space of hazardous gas, vapor, dust, fume or free flowing solid and liquid. A confined space should be adequately purged before the entry of workers to ensure that no sludge or other deposits will give off hazardous gas, vapor, dust or fume during the course of work. If steam cleaning is used, sufficient time should be allowed for cooling to ensure that it is safe to work in the confined space. Is the entrance big enough to allow workers wearing all the necessary equipment to get in and out easily and provide safe access and egress in an emergency? For example, if the entrance is narrow, airline breathing apparatus should be used instead of self-contained breathing apparatus, which is more bulky and therefore restricts passage. You may increase the number of openings and therefore improve ventilation. Mechanical ventilation may be necessary to ensure an adequate supply of fresh air. Do not use oxygen to freshen the air inside the confined space, as this will greatly increase the risk of fire or explosion. Adequate supply of fresh air is of particular importance if compressed gas or burning equipment is used inside the confined space because of the danger from built-up of engine exhaust. This is necessary in order to check that the air is free from both toxic and flammable gases, and that there is no deficiency in oxygen and the air is fit to breathe. Testing should be carried out by a competent person using a suitable gas detector which is correctly calibrated, where the risk assessment indicates that conditions may change in the course of work, or as a further precaution, continuous air monitoring as advised by the competent person is required. Non-sparking tools and especially protected lighting are essential where flammable or potentially explosive atmosphere are likely. In certain confined space, for example, inside metal tanks, suitable precautions to prevent electric shock include the use of extra low voltage equipment, voltage not exceeding 50 volt, alternating current or 120 volt direct current whether between conductors or to earth, and where necessary residual current device. Where the use of approved breathing apparatus is recommended in a risk assessment report, or entry into a confined space for underground pipeline is required. It is required to ensure that any person entering or remaining in the confined space is properly wearing an approved breathing apparatus of a type that give appropriate protection given the nature of the confined space, is wearing a suitable safety harness connected to a lifeline that is strong enough to enable him to be pulled out, and that the free end is held by a person staying outside the confined space who has sufficient physical strength to be capable of pulling the worker out of the confined space in an emergency. The person must remain in situ throughout the course of work. You must issue a safety certificate which ensure that all the safety precautions are in place and a formal check has been undertaken before workers are allowed to enter or work in the confined space. The certificate specifies the period during which worker may remain safely in the confined space. It is also a means of communication between site management, supervisor and those carrying out the hazardous work. Essential features of a safety certificates are location of the confined space, name of workers who are going to enter the confined space, name of person who may authorize particular jobs and any limits to their authority, risk control measures, name of the person who is responsible for specifying the necessary precaution, for example, isolation, air testing, emergency arrangements, etc. Name of person staying outside the confined space and period during which worker may remain safely in the confined space. The last principle of safety precaution for confined space is devise an appropriate emergency plan before the work starts. To deal with any serious and imminent danger to workers inside a confined space, appropriate emergency procedure should be formulated and implemented according to the nature of the confined space, the risk involved and the nature of an emergency rescue. Provide and keep readily available in a satisfactory condition a sufficient supply of approved breathing apparatus, suitable breathing apparatus, vessel containing oxygen or air, safely, harness and ropes, an audio and visual alarm for alerting others outside the confined space. How can an emergency call be communicated from inside the confined space to people outside so that rescue procedures can start? Don't forget that an emergency may occur during night shifts, weekend and times when the premises are closed. For example, public holidays. Also consider what might happen and how the alarm can be raised. Procedures to notify emergency services departments, for example, fire service department, in case of an emergency should be formulated in advance. Preparation should also be made to provide these emergency services departments with relevant information on their arrival to help them understand the dangers in the confined space. Let us conclude this lecture and learn about the key act, rules and regulations and officers pertaining to confined spaces. In India, confined spaces are regulated by various laws and regulations to ensure the safety of workers and prevent accidents. The primary legislation governing confined spaces in India is the Factories Act 1948, along with associated rules and regulations. Additionally, other regulations such as those issued by the Directorate General of Mine Safety may apply to specific industry like mining. Here are some key act, rules and regulations related to confined spaces in India. The Factory Act 1948. In section 2C defines a confined space as any place including any chamber, tank, vat, pit, etc., where dangerous fumes, gases, dust or other substances are likely to be present. Section 41B of the Factories Act mandated that in confined spaces where there is a risk to health or safety, a competent person should conduct a risk assessment and formulate a written scheme to ensure safety. Section 42 requires the employers to provide necessary precautions for the safety of workers in confined spaces. The Manufacture, Storage and Import of Hazardous Chemicals Rules 1989. These rules apply to industries dealing with hazardous chemicals and include provisions for safe storage and handling within confined spaces. Occupational Safety and Health Code 2020. The Ministry of Labour and Employment introduced the Occupational Safety, Health and Working Condition Code in 2020, which provides for safety and working conditions, including regulations concerning confined spaces. The Mines Act 1952. This act, along with regulations issued by the Directorate General of Mines Safety, governs safety in mining operations, including the safety of workers in confined spaces in mines. Indian Boiler Act 1923 and associated rules. These regulations pertain to boilers and pressure vessels and may apply to confined spaces where boilers or pressure vessels are located. Petroleum and Natural Gas Safety in Offshore Operations Rules 2008. These rules apply to offshore oil and gas operations and may include provisions related to confined spaces on offshore platforms. Indian Standard. Various Indian standards issued by the Bureau of Indian Standards provide guidelines and specifications for safety in confined spaces. Local state regulations. In addition to national regulations, some states in India may have their own rules and regulations governing confined spaces. It is essential to check with local authorities for specific requirements. In India, various officers and authorities are involved in enforcing and ensuring safety in confined spaces. These officers play crucial roles in implementing safety regulations and standards. Here are some of the key officers and authorities involved in confined space safety. Factory Inspector, Chief Inspector of Factories and Boilers, Directorate General of Mine Safety, Petroleum and Explosive Safety Organization, Local Industrial Safety Authorities, Occupational Safety and Health Officers, safety committees, competent persons, emergency response teams, government inspectors and auditors. So, in this lecture we have discussed about the confined space, classification of confined space, hazards in confined space, safety precautions, acts, rules and regulations related to confined space, and about the officers those are involved in confined space. With this, we will end our today's lecture here. Thank you for your patience. Thank you.